Good morning, welcome to my laboratory. What I'm going to do now is demonstrate current flow. Okay, so this is part 5, and the schematic that we're using is the full, ordinary, regular old Ainslie schematic, with the exception that I only have one Q2 in there and one Q1. The rheostat is not in use. I have a 1 ohm current viewing resistor, and to make this a Q1 I just pulled it out and turned it around, and then this one is the Q2 over here. 10 ohm load of 2 wire wound resistors, black function generator lead at the, where is it? It's this one, at the common ground. Red function generator lead to the gate of Q1 and the source of Q2, just like always. I'm using two 12-volt batteries for 24 volts, and what I've done is I've put in a simple digital multimeter, this one, in series with the negative lead of the battery supply. So this is strictly a series ammeter in there, and I have it on the 200 milliamp range. And positive indication here will be indicating current flowing in the conventional direction around the circuit, out of the battery into the load. Okay. This meter will be monitoring the voltage on the gate, the applied voltage to the gate of the MOSFET, and I will go ahead and turn it on right now. Okay. Why is it indicating a negative voltage right now? Okay, right now it's indicating a negative voltage because it's seeing some of the drive from my function generator, so don't worry about that right now. Okay, here are the baselines of the two channels. This is the function generator channel down here, and that's the signal that it's putting out right now. It's idling. This top trace is the current viewing resistor, and we're looking at that right now at, let's go ahead and put it at 1 volt per division. A 10x attenuated probe, 1 volt per division on this top trace here. This bottom trace is at 5 volts per division with no attenuation, as it always is. Now, okay, so now what I'm going to do is put in a little offset by pulling out the offset knob. Okay, and then I'm going to turn up the amplitude. And I think you can see that we have nice oscillations, and right about there we're starting to see some lifting on the Q1 trace, like that, right? Okay, so now what I'm going to do is put the meter up here so that it can be seen at the same time, hopefully, as the scope display. It's not too bad. Okay, so now I'm going to go ahead and establish some oscillations with about 4 volts positive gate drive. Okay, about 4 volts positive gate drive. Plenty of oscillations, but we haven't started seeing the lift of the Q1 trace yet. But this is pulsing at 1.6 kilohertz. So the meter is not really giving us a good accurate indication, right? Or at least that's the excuse. So what I'm going to do now is slow the function generator down. Okay, so now we have, oh, and I need to make it symmetrical. Alright, so now we have a function generator low portion, function generator high, low, high. I've just slowed it way down, okay? And the reason for this is so that we get a chance for the meter to settle and read DC current at those values, okay? Can I get it to go any slower? Oh yeah, I can. Okay, hang on here. Okay, so the function generator low, slow it down even more. Function generator high, low, high, low, high, low. So I think you can see that there's a positive current being flowing from the battery in both the function generator high, no oscillation, and the function generator low setting, right? This is only, 31 or 40 milliamps, but now watch what happens. Oh, we wanted the gate voltage too, right? Okay, so the positive gate voltage, we have -3, +3.9, -3, +3.9, -3.1, +3.9. Okay, now the negative is of course happening with oscillations down here. You got some oscillations, but the positive is straight DC. So I think that you can see that when we apply 3.9 volts to the gate of this MOSFET system, we get definite current flow, 30-40 milliamps. And then when we're in the oscillation mode, we have more current flow, 66 milliamps or so. Now if I turn up the positive gate using the function generator amplitude here until we start getting, see there, I exceeded the 200 milliamp range already. See there? So you're starting to get a little bit of lift off the baseline on the scope, but the meter indicates 200 milliamps or more, even with just barely, let's see, what is the voltage there? The positive voltage on the gate. Slightly over 4 volts, and we've already turned the MOSFET on hard enough to exceed the 200 milliamp range of this meter. Alright, now let's go ahead and go back up to the original rate there. Get back to that scope shot there, and you can see a substantial lifting of the gate of the current trace there. That should be right on the baseline. So even with that slightly over 4 volts, we're still getting substantial current indicated. And if I go right down to 4 volts, we still see current indicated. And if I go down even further to where the Q1 current is off, I still have Q2 current. Alright? And in fact, even just barely any at all, I still get some current there. Alright? Thank you for watching.